Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about absolute value equations. When we're dealing with absolute value, here's your symbol here. These two vertical lines with anything between them, that means you're trying to take the absolute value of whatever that quantity is. In order to find the absolute value, you're basically trying to find the distance to zero. So whatever this value is inside of these two vertical bars here, this value, in this case x, is simply the distance to zero. Because you're looking at the distance to zero, you can have the same exact distance whether you're coming from the left of zero or the right of zero, which is why in most cases you'll end up with more than one answer when dealing with an absolute value equation. So let's check out this example right here. Let's say that I'm trying to find the absolute value of x, which equals to 3. Well, ladies and gentlemen, here on my number line I'm showing that the distance to zero that equals to 3 would be if I were to begin at -3, and also if I would start at +3. I would still be 1, 2, 3 places away from zero either way. Okay, because of that, you would end up with two solutions: x equals to -3 and x equals to +3. Keep in mind, ladies and gentlemen, that the end result of any absolute value will equal to either 0 or a positive number. So for instance, if I were to plug in -3 back into the original equation here, the absolute value of -3 is +3 because it's 3 places away from 0. As well as if I were to take the absolute value of +3, that is 1, 2, 3 places away from 0. So that's why you would end up with two solutions for this example right here. Alright, let's look at some additional problems. Let's check it out. In problem number 1 here, we have the absolute value of 2x equals to 4. There are 4 steps that I always want you to do when you are dealing with an absolute value equation. Step 1 is to always start by isolating the absolute value. That's right. Get that absolute value symbol by itself, and in this case it already is. Step 2 is the most important step, and that is analyze. Determine whether or not your absolute value is possible, meaning that the absolute value, once you have it isolated, it should equal to either a positive number or to 0. So in our case here, we do have a positive value on the right side of our equal sign here. Alright, so because it is possible, we'll move on to step 3. And step 3 is to set up two different equations, one coming from the left of 0 and the other coming from the right of 0. So here I'll begin by saying that I have 2x equals to 4, which takes care of the distance coming from the right, and I can also set 2x equals to -4, because remember, the absolute value of +4 still equals to 4, and the absolute value of -4 will also equal to +4. Therefore, you'll need to set up two different equations. From there, we'll go ahead and solve for x. So next, I'll be dividing both sides by 2. I have my 2's canceling out, and x equals to 2. Then on the right side, I can divide both sides by 2 here, and x equals to -2. Alright, so we can always check our answers by plugging the results back into the original problem. So for instance, here I have x equals to 2. If I were to plug in 2 back in the original problem, 2 times 2 is 4, and then the absolute value of 4, in other words, the distance from 0 to 4 is 4, so that works out. Using -2 as our possible solution, you'll have 2 times -2, which is -4, and then the absolute value of -4, the distance from -4 to 0, is a +4, so that works out just fine. So our solution for this problem will be x equals to, let's see if I can get a decent brace. That's decent. Alright, that one's not so good, but we're going to be okay. So that answer is -2, 2, ladies and gentlemen. That's right. Those two solutions will equal to the answer. Let me go ahead and box that up. I like to box it up in red. There it is. That's it. That's problem number 1. Let's check out the next problem. In problem number 2, we have the absolute value of 6 plus 2x equals to -3. Right away, ladies and gentlemen, we notice that the first step has been done. The absolute value is already isolated on one side of the equal sign. However, in our second step, step 2, where we're supposed to analyze the absolute value equation to see if it's possible, here the absolute value is set equal to -3. Well, the only possible solutions for an absolute value is either a positive number or 0. It can never equal to a negative number because we don't deal with negative distances in real life. So there's no need to continue any further. This is the null set, aka no solution, ladies and gentlemen. So here is my big red box, or you can write out no solution. Either way, ladies and gentlemen, it depends on your teacher. All right, and a box goes for no solution as well. So either or, okay? There you have it. That's problem number 2. Here we are, moving on. Problem number 3, we have the absolute value of 2x minus 1 divided by 3, which equals to 5. Well, my absolute value is isolated. It's on one side of the equal sign. And even better, we have it set equal to a positive number, which means we can solve this problem. So that means I'll be setting up 2 different scenarios here. The first, I'll have 2x minus 1, in other words, just dropping those absolute value symbols. 2x minus 1 divided by 3 equals to 5, and I'll also have 2x minus 1 divided by 3 equals to negative 5. Remember, you'll need 2 equations, one to take care of coming from the right of 0 and the other one to take care of coming from the left of 0 to have a distance of 5 from 0. So from there, I'm going to choose to multiply both sides here by my denominator of 3. All right, I like to clear out my fractions. So this is going to be 3 times 2x minus 1 divided by 3 equals to 3 times 5. That's right, multiplying each and every term by that common denominator. What that allows me to do is to cancel out these 3's here. All right, so now I have my equation rewritten as 2x minus 1 equals to 15. From here, I'll be adding 1 to both sides. That's right, adding 1. 1's cancel out. I have 2x equals to 16, and then finally, you got it, I need to do what? Yes, that's right, I need to divide both sides by 2. How did you know that? Good stuff. Not bad on your part. Okay, so x equals to 8. Yes, that's a possible solution there. And I say possible solution, ladies and gentlemen, because you can sometimes have extraneous solutions, which means that your answer, though solved algebraically correct, it may not work in the original equation. So that's why you should always test your answers to see if it's possible. All right, trying this second equation here, what we'll do is we'll once again start by, let me go ahead and separate this. We'll go ahead and multiply both sides by 3. So here I'm multiplying each and every term by 3, and that helps me get rid of those fractions that we have here. From there, ladies and gentlemen, I'll be canceling out those 3's. I'll be bringing down the 2x minus 1, which equals to negative 15. And then I'll be adding 1 to both sides, just like so. From here, I have 2x equals to negative 14, and then I'll be dividing both sides by 2. All right, so dividing both sides by 2, we end up with x equals to negative 7. So remember to try your values back in your original problem to see if it works. Let's see what happens here. If I were to plug in 8 back into the original equation here, I would have 2 times 8 is 16, and then 16 minus 1 gives me 15. 15 divided by 3 is 5, and then the absolute value of positive 5 is positive 5. That works. Next, go ahead and try that negative 7. 2 times negative 7 is negative 14. Negative 14 minus 1, that's negative 15. Negative 15 divided by 3 is negative 5, and then the absolute value of negative 5 is 5. So that verifies that both of these solutions will work, ladies and gentlemen. So here, we'll end up with x is equal to negative 7 and 8. That's it. There you go with those ugly brackets again. One of these days I'll get that down. All right, so negative 7 and 8. That's it. That's the solution. On to the next example. Let's check it out. Here in this problem, we have problem number 4. Problem number 4. And in problem number 4, we have 2 times the absolute value of 2x minus 7 plus 11 equals to 25. Follow the steps that I gave you, and we can get to the solution. Step 1. Isolate the absolute value. Let's get it by itself. So in order to get the absolute value by itself, I'll be subtracting 11 to both sides. 11's cancel out on the left side. I bring down 2 times the absolute value of 2x minus 7, and this equals to 14. My next step is going to be dividing both sides by 2. So I'll divide both sides by 2, and I'll end up with the absolute value of 2x minus 7 equals to positive 7. Once I have this, notice that I do have my absolute value isolated, and it's equal to a positive value. Remember, as long as your absolute value is equal to 0 or a positive number, it's solvable. you can work it out. So this being the case, we'll go ahead and set up our two equations from here. The first equation, I'll just drop the absolute value bars and I'll end up with 2x minus 7 equals to 7. The second, I'll have 2x minus 7 equals to negative 7. So these will be my two equations that I'll solve. From here, I'll be adding 7 to both sides. This gives me 2x equals to 14, and then I'll divide both sides by 2. Dividing both sides by 2 gives me a value of x equals to 7 as a possible solution. And the second equation, I'll be adding 7 to both sides. I'll have 2x equals to 0, and then I'll divide both sides by 2. So I find out that x equals to 0 as a possibility. Now let's go ahead and check these results to see if they'll work in the original problem. So we have 0 and 7 as possible solutions. Trying out 0, we'll have 2 times 0, which is 0, minus 7 gives us an absolute value of negative 7. The absolute value of negative 7 is 7, and then 2 times 7 is 14. 14 plus 11 does equal to 25. So we know that 0 works out just fine. Testing our other solution, which is 7, we'll have 2 times 7, which is 14. 14 minus 7 is 7. The absolute value of 7 is 7. 7 times 2 is 14, and then once again 14 plus 11 will give you 25, so that works out just fine. So thus far we have not encountered any extraneous solutions, but you should always check to make sure. Alright, so here we have a solution set of 0, 7, and my ugly braces. Alright, so boxing that up, those are my two answers for problem number 4. Alright, let's see what we have next. Problem number 5 coming up. With problem number 5, we have the absolute value of 7x minus 2 equals to x plus 4. Remember, following our first step, we'll want to isolate the absolute value, which is already by itself on one side of the equal sign. So we don't know whether this value of x plus 4 is going to be equivalent to a positive value or a negative value, so we'll go ahead and assume that we can solve this problem. So let's go ahead and drop the absolute value bars, and we'll write our first equation as 7x minus 2 equals to x plus 4. Your second equation, ladies and gentlemen, will look like this. You'll have 7x minus 2 equals to the opposite of x plus 4. So therefore, I'm putting a negative around the quantity of the right side of that equal sign, which in this case was x plus 4. From there, go ahead and solve both equations. And remember, we'll need to check our answers to see if it will work in the original problem. So I'll start by subtracting x to both sides of my equal sign here. This cancels out the x's on the right side. I'll be bringing down 6x minus 2, which equals to 4. From there, I'll be adding 2 to both sides. All right, this gives me 6x equals to 6, and then I'll need to divide both sides by 6 in order to solve for x, which now I know is possibly 1. All right, so that's one of the first possibilities that I have. Looking at the second equation, I need to distribute this negative into the parentheses. So I'm going to get my arrows popping. That's right, got my arrows popping, ladies and gentlemen. Anytime I use a distributive property, I need to remind myself whatever value I have on the outside of the set of parentheses needs to be multiplied with everything on the inside. So I'll be bringing down my 7x minus 2, which equals to negative x minus 4. Amen, amen. From there, I'm going to be adding x to both sides of my equal sign. All right, so adding x to both sides here. I end up with 7x plus x. That gives me 8x minus 2, which equals to negative 4. All right, then go ahead and add 2 to both sides. Okay, 2's will cancel out on the right side, and bringing down 8x, it will be equal to negative 2. Then what do? You'll go ahead and divide both sides by 8. Then, simplifying this further, we'll have x equals to negative 1/4 after reducing that negative 2/8. Once you have your possible solutions, don't forget to check your answers in their original equation to see if it works. So plugging in 1, as we check for extraneous solutions, you'll have 7 times 1, which is 7, and then 7 minus 2 is 5. The absolute value of 5 is 5, all right? Then on the right side, 1 plus 4 That equals to 5 as well. So therefore, 1 checks out just fine. All right, that solution works. Now, trying your negative 1/4. Plugging in negative 1/4, this becomes negative 7/4 minus 8/4 to give you a negative 15/4. Well, the absolute value of negative 15/4 is a positive 15/4. All right, then over here on the right side, you'll have negative 1/4 plus 16/4. That's converting that 4 over 1 into 16 over 4, by the way. So negative 1/4 and a positive 16/4 combines to give you a positive 15/4, which matches what I just got on the left-hand side, which means both solutions will work, ladies and gentlemen. So my solution set for problem number 5 is going to be, I'll give a brace here, negative 1/4 and 1. That's it. They both work in the original equation. But like I said, you always want to check to make certain, ladies and gentlemen, okay? So that's problem number 5. All right, good stuff. Let's keep it moving. In problem number 6, notice that we have a absolute value sign on both sides of the equation. So here I have the absolute value of x plus 5 equals to the absolute value of x minus 7. So starting out, we are always following our steps here. Step 1 is to isolate the absolute value. And in this case, since we have 2, all you really had to do was isolate one of them. Okay, so both of them are isolated, so we're already good. Then the second step is to analyze the problem. Remember that when finding the absolute value, you'll either end up with a positive result or 0. So because both of these are absolute value signs, then this must be possible because they're both going to validate the other one, meaning that this one will either be a positive number or 0, and this one will be either a positive number or 0. So therefore, it makes the equation possible. All right, so let's go ahead and set it up from here. Let me show you what to do. For our first equation, you simply drop the absolute value bars. So I'll write this as x plus 5 equals to x minus 7. Your second equation, you'll have the opposite value of that x minus 7. So I'll have x plus 5 equals to the opposite of x minus 7. All right. So notice that in this situation here, I only really have to find the opposite of one of those, all right? Because we're talking about the same distance to 0. When I attempt to solve for the first equation, notice that if I subtract x to both sides, the x's cancel out and 5 equals to negative 7. Notice that this is a false statement. Well, if it's a false statement, that means that this is not possible. There's no way 5 equals to negative 7. So therefore, we can ignore this equation altogether. There's no way that's going to be true. So we'll work on the second equation here. And I'll start by getting my arrows popping in order to distribute that negative there. So I'll rewrite this as x plus 5 equals to negative x plus 7 after distributing that negative 1. Then solving for x, we'll go ahead and add x to both sides of the equal sign here. This gives me 2x plus 5 equals to 7. Then I'll be subtracting 5 to both sides. I'll have 2x equals to 2. Then I'll be dividing both sides by 2, that coefficient in front of the variable x there. So x possibly can be 1. So let's go ahead and try the only solution we were able to get out of this. So going back to the original problem here, we would plug in 1, and 1 plus 5 is 6. The absolute value of 6 is 6. Plugging in 1 here into the second absolute value, 1 minus 7 is negative 6, but the absolute value of negative 6, you got it, it's positive 6. So that means that works out just fine, ladies and gentlemen. So your solution set here is just going to be the value of 1. That's it. X equals to 1 and only 1. There you go. That's problem number 6, ladies and gentlemen. Next, we'll be looking at problem number 7. With problem number 7, we have the absolute value of x squared minus x equals to 6. So in this problem, ladies and gentlemen, we're going to be doing the following here. We're going to first of all notice that it is isolated. The absolute value is already isolated on one side of the equal sign. The second thing to do is to analyze the problem. So is this value set equal to either 0 or a positive number? Well, you're right. It is set equal to a positive number, so that means we can solve it. So let's go ahead and work this problem out. Working out problem number 7, you'll simply drop the absolute value bars here. You'll have x squared minus x equals to 6, and then you'll have a second situation where you have x squared minus x equals to negative 6. Remember, you need a separate equation for the distance to the right of 0 and the distance to the left of 0. It had to be 6 places away from 0, which is why we ended up with a positive 6 and a negative 6. Once we have this, then solving for x, I'll be subtracting 6 to both sides in the first equation, and I'll end up with a quadratic equation that reads x squared minus x minus 6 equals to 0. Fortunately, this happens to be factorable, right? So I would be looking for two numbers that will multiply to give me 6 and subtract to give me 1. Well, those two values are 3 and 2. So I can factor this into x minus 3 times x plus 2 equals to 0. All right, so yes, indeed, I am using the zero factor property. So if you need a review over that, check out our video on solving quadratic equations using the zero factor property. From here, I'll be setting each one of these factors equal to 0. So I have x minus 3 equal to 0, and then I'll have x plus 2 equals to 0. Solving for the first equation, I end up with x equals to 3, and solving for the second one, I have x equals to negative 2. All right, that's a negative sign right there. So these are the possibilities that we have from the first equation. If we were to add 6 in our second equation from the beginning here, you'll end up with x squared minus x plus 6 equals to 0. Well, if you're going to test to see if this is factorable, you would be looking for two factors of 6 that would add to give you negative 1. Well, that's not going to happen. It's not possible. So this tells me that you're going to have one of two situations. You're going to either have no solutions because they'll be imaginary, or you'll end up with irrational solutions. Remember, you can always tell what type of solutions you'll end up with if you use the discriminant when you're dealing with a quadratic equation. So that's exactly what I'm going to do. In order to get to discriminant, I'll be using the formula b squared minus 4ac. So my a value would be 1, my b value is negative 1, and my c value is positive 6. Plugging these values in, I have negative 1 squared minus 4 times 1 times 6. This gives me a result of 1 minus 24, which equals to negative 23. Anytime your discriminant is negative, ladies and gentlemen, that means you're going to end up with imaginary numbers. Due to the fact that we're looking for the distance to 0, ladies and gentlemen, the imaginary numbers, unless requested from your instructor, are not necessary at all. So the only real possibilities we have are 3 and negative 2. So let's test these out in the original equation. Let's test negative 2. Plugging in negative 2 squared is positive 4, and 4 minus a negative 2 is the same thing as 4 plus 2. 4 plus 2 equals to 6, and the absolute value of 6 is 6, so that works out. Then let's plug in our other possible solution, which is positive 3. 3 squared gives us 9, minus 3 is 6, and the absolute value of 6 equals to 6. So that means that for problem number 7, both negative 2 and 3 are solutions to this equation. So we'll have x equals 2, and let's get our solution set together. We'll have negative 2 and 3. All right, and that's going to do it for problem number 7, as well as this lesson on solving absolute value equations. Once again, ladies and gentlemen, please rate, comment, and definitely subscribe. If you like what you're seeing, ladies and gentlemen, and you're able, go ahead and donate if you can to keep bringing you free math videos. Thanks a lot, ladies and gentlemen. Peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.